Alrighty guys, we're going to talk more about multiplying in this video, but we're going to be multiplying bigger nomials. So multiplying, and we're going to do not just a monomial anymore. That's kind of too easy. It's just distributing. We're going to do like a binomial times a binomial, or maybe a binomial times a trinomial, or maybe we'll get even crazier than that. And we're going to do that on page 95. Now, 96 across from it is sort of related, but we'll talk about that separately. So if we turn to page 95, we have this great little booklet right here where we are going to do some multiplying madness. Now, the way that I like to think about multiplying lots of numbers by lots of numbers is to still really think about distribution. But the thing is, if I need to multiply each of these numbers, these two numbers here, by these three numbers there, then it's almost like I'm distributing twice, okay? So each term of the first gets distributed to each term of the second. So that means I kind of take this one and I distribute it here, here, here. So I took the first and distributed it to all that. So that each term of the first polynomial gets distributed to each term of the second. So the first one gets distributed. And then the second one gets distributed. So it goes to the first, to the second, and to the third. Okay? So when you do that, you're multiplying two numbers by three numbers, which really means you should end up with 6 numbers. So that's a good way to know that you have the right amount. So if we go through this carefully, I'm going to get all of my pink numbers first, and then we'll get all of our green numbers second. Boop, boop, boop. So x times 2x squared will be 2x to the third. X times x, really negative x, will be negative x squared. Then finally, x times 3 will be a positive 3x. So I took this one and I multiplied it by each of those. Then I want to take the second number and multiply it by each of these. So 2 times 2x squared is 4x squared, positive. 2 times negative x will be negative 2x. And then 2 times 3 is 6, positive, so plus. Then we just want to go through and combine any like terms, and you will have like terms when you do this. So I don't have any x to the thirds except for that one, so it's going to stay 2x to the third. Then I want to look for my x squared so that we can stay in standard form, and I have negative 1 of them here and 4 of them there. So these guys are the same, and we have 3x squared, positive, so plus. Then I'm looking for my x's, and I have 3 x's there and negative 2 x's there for a total of 1x, positive, so plus. And then we have this 6 just chilling on its own, so plus 6. And there's your final answer. Now there's a couple other ways I'm going to show you depending on the type of polynomial, but we just got a whole bunch to try now, because practice makes perfect. So when I'm doing a binomial by a binomial, I'm doing 2 numbers by 2 numbers. I'm going to end up with 4 numbers. So if we think about this first column the same way that I did the last one, I would do, and I'm not going to draw this out on every single one, but I would do the x times the x, and then the x times the 2. So I did that one by each of the second one, and then I do the second one by each one, and there you go. So if I do it now, x times x is x squared, x times 2 is positive 2x. 1 times x is 1x. 1 times 2 is 2. You will have like terms, and I see them right in the center there, so we'll have x squared plus 3x plus 2. So kind of continuing that with this one, and then I'll kind of show you another way to do it. If we take this first one and distribute it to both, and then take the second and distribute to both, so I distribute twice, I get x times x for x squared, x times negative 2 for negative 2x. In the center here, I get positive 8x and negative 16. Combine like terms in the middle. They always seem to be in the middle. So I'll have x squared plus 6x minus 16. Then moving down, we're going to do x times x for x squared, x times 3 for 3x, 5 times x for 5x, and 5 times 3 for 15. Combine like terms, so we got x squared plus 8x plus 15. Oop. And then the last one that I'll do that way, we got x times x, so x squared, x times negative 2 for negative 2x, 4 times x for 4x, and 4 times negative 2 for negative 8. Combine my like terms, so I'll have, oh my god, you can't see what I'm doing at all. Sorry. And then we'll combine like terms. We got x squared plus 2x minus 8. Oopsies. It's just real hard to write on this page. It's like leaning off my notebook in a really awkward way. So another way to think about it that some teachers really like to use over and over again, so you don't want you to be confused if you hear a teacher in the future use this term, is based on what I'm doing here. The first thing that I do is I multiply the first by the first. Then I do the outer terms, like on the outermost edges. Then I do the innermost terms, like these inner, like the inners, so I. And then I do the last term in each. So some teachers will use the acronym FOIL for first, outer, inner, last to talk about the order that you're multiplying. So you could use that as a nice little reminder. I'm going to do the first times the first for x squared. Then the outer terms, so 6 times x, so 6x. Then the inner terms, so negative 4x. And then the last terms, so negative 24. I don't mind this way. This way is fine. The acronym is nice. There are 4 letters, so it'll remind you that you have to have 4 numbers. And then we combine our like terms, and you'll always end up with that being either actually 2 or 3 numbers after that, depending. So plus 2x minus 24. So if I think first, outer, inner, last, first times first is x squared. Outer is negative 3x. Inner is negative 7x. And last is positive 21. Combine my like terms. So I'll have x squared minus 10x plus 21. Moving right along, if I think FOIL, first, outer, inner, last, first times first is x squared. Outer is 9x. Inner is negative 8x. And last is negative 72. Combine my like terms, so we'll have x squared plus 1x minus 72. And you can put the 1 or not. And then the last one here, we're thinking FOIL, first, outer, inner, last. If I do first times first, we get x squared. Outer, we'll have negative 1x. Inner, we'll have negative 6x. And last, we'll have positive 6. Combine our like terms, so we have x squared minus 7x plus 6. Now, another way that I like to do it is thinking back to when I first learned how to do like big multiplication, like 2 numbers by 2 numbers. You sort of stack them. So I could take my binomial and sort of rewrite it, where I put 4x plus 1 on top and then x plus 4 on bottom like this. And I do some old school multiplication. So when you did this, you multiplied up, and that was 4. You multiplied across, and that's 16x. I put a placeholder, and then I go here and I multiply backwards like this for 1x, and then I multiply up, and 4x times x is 4x squared. And then you should just be able to add down and get your simplified polynomial for 4x squared, 17x, and then 4. So I like to call that old school multiply. So you could do that, and I'm going to do that for all these here. So if I stack these, minus y, ooh. If I multiply here, we get negative 3y. If I multiply here, we get negative 6xy. If I multiply diagonally here, we get, placeholder, 6x. Ooh, those are not like terms. And then I get 12x squared. I kind of smushed that in there real bad. Now, I just noticed on this one, they were like terms in the middle, but on this one, they're not, because this is an xy and that's just an x. And in fact, I don't see any like terms here. So I'm just going to write this out, 12x squared minus 6xy plus the 6x minus 3y. So that's kind of a weird thing that happens, especially when I literally just said you'll always combine like terms, but I guess not if there's random letters in there. So moving on down, if we take a look at this one, if I stack them, now this one doesn't have other random letters going on there, so we should be able to combine like terms. So 2 times 1 is 2, 2 times 2x is 4x, put my placeholder, x times 1 is 1x, x times 2x is 2x squared. Yeah, and now I do have like terms, so when I add it up, we'll have 2x squared plus 5x plus 2. Alrighty. Last one I'm going to do like that. So 3x plus 8 is already there. I'm just going to put the 2x minus y underneath. Ooh, and because it's funky letters, we're not going to be able to combine like terms probably. So when I multiply up, we got negative 8y. When I multiply across, all the letters are just going to smash together. Placeholder. When I multiply here, we get 16x, so not like terms. And then when I multiply here, we get 6x squared, which is also not a like term with anybody else. So 6x squared minus 3xy plus 16x minus 8y. And I should say too, like, I'm not super particular about the order here. Like if you had the 2 middle ones swapped, I probably wouldn't care, even though this technically has a higher degree than that, but whatever. Now the last one I would do, like this last column, I would kind of do however you like. So I don't know. Oh, no, I have one more way to show you. The box way. I forgot the box way. Oh, the box way is so good. So if you set up a box, a 2x2 box, and it's 2x2 because I have 2 terms and then 2 terms. So if I put outside the box along the top, the x and then the minus 9, not a q. And then on the other side of the box, the negative 2x and then the positive 1. We want to like multiply. We did this in class and I can't believe I almost forgot. We want to multiply to get the area of each square. So like I multiply here to get negative 2x squared. And then I multiply here to get 18x. I multiply here to get 1x. And then I multiply here to get negative 9. And then along the diagonal, you should have like terms as long as there aren't any funky letters. And so we get negative 2x squared plus 19x minus 9. Oh, I can't believe I almost forgot the box. Alrighty, setting up a box on this one. We got x minus 5 along the top, x minus 8y along the side. We're not going to have like terms because of that friggin' y. So x times x is x squared. X times negative 5 is negative 5x. X times this negative 8y is just going to be negative 8xy. And then we'll have positive 40y. So looking along the diagonals, I don't have any like terms. So we're just going to write it all out. So x squared minus 5x minus 8xy plus 40y. On to the next. Setting up a box 2 by 2. So it's x minus 4 and then negative 5x plus 6. And when I multiply here, we'll have negative 5x squared. Here we'll have 20x. Here we'll have 6x. And then negative 24. Oh my gosh, I feel like I've done so many of these, I forgot how to multiply. Anyways, I do have like terms. We'll have negative 5x squared, then 26x, and then minus 24. Last but not least on this page, am I going to really do this all in one video? Maybe I'm not. I don't know. How long has it been? Not that long. Let's keep going. If I set up this box, I'm going to have x minus 7 and then x minus 3y. Oof. Not going to have like terms this y because of that y. This time because of that y. Oh my god. X times x is x squared. X to negative 7 is negative 7x. These are all just going to smash together as well. Negative 3xy and then 21y. And again, as I look through, no like terms. So we get x squared minus 7x minus 3xy plus 21y. All right, let's kick it up a notch. Binomial times binomial is fun, but a binomial times a trinomial is thrice as much fun. I don't know. So here I'm doing 2 numbers times 3 numbers. Now truly, we could do like I did on the first one, where I distributed the first number to all 3 in the second polynomial. Then I took that second number and distributed it to all 3 of the second polynomial. And that's a super fine way to do it. So x times x squared is x to the third. X times x is x squared. X times 2 is 2x. And they're all positive, so plus. Then I go to the 1, and I do 1 times x squared, so 1x squared. 1 times x, so x. And 1 times 2, so 2. Then we collect our like terms. So I have only this x to the third, but then I have an x squared here and an x squared there for 2x squareds. And I have a 2x here and a 1x there for 3x's. And then just this chilling 2 at the end. Now, I did that same thing with the binomials times the binomials on the first column. Now, the second thing I did was this cute little acronym. Unfortunately, there's not a cute little acronym for a binomial times a trinomial. However, you could do this old school multiply thing here. So the way that I like to do it is I like to put the bigger number on top. So I would take that x squared plus x minus 2, because it's 3 numbers, and put that on top, and then the x minus 8 on bottom. And we can straight up multiply like this. So negative 8 times negative 2 is positive 16. Negative 8 times x is negative 8x. And negative 8 times x squared is negative 8x squared. I need a placeholder, and then I'm doing the x times each one. So x times negative 2 is negative 2x. X times x is x squared, and x times x squared is x to the third. Now, the reason I really like this way is because it lines everything up for me. Like all my like terms are sort of in the same positions. So I have 16, and then negative 10x, and then negative 7x squared, and then x to the third. I don't know why I kind of did that backwards, but. And then truly, you could also do the box method. So I did the box method 2 by 2 because it was a binomial times a binomial. This is a binomial times a trinomial, so I'm going to do a 2 by 3 box. And I kind of like this one because it helps me stay organized and not forget anybody because I have to fill each square. So along the 2 side, I'm going to put the 3x and the -8 because those are the binomials. And then along the 3 side, I'll put the 3 numbers. So x squared minus 2x and minus 4. Then you just have to multiply to fill each box. So 3x times x squared is 3x to the third. 3x times -2x is -6x squared. And then -12x. Sorry, I'm writing really awkwardly again because it's leaning off the paper. Then I got to multiply the -8 by each, so -8x squared, positive 16x, and then positive 32. Along your diagonals, you should have those like terms again, as long as there are no funky numbers or letters. So 3x to the third minus 14x squared. That's a -12, so 4x, and then plus 32. The last one I'll leave for you. This video is getting long. A trinomial by a trinomial. Now you could distribute this one to each of those. Let's just do it. Then I got to take the middle one and distribute it to each of those. Then I got to take the last one and distribute it to each of those. I don't have another space to put it. So this one I'm distributing 3 times, and that can get real messy and confusing. But let's try it out. So x squared times x squared is x to the 4th. X squared times 2x is 2x to the 3rd. X squared times -1 is -1x squared. And then I'm done with that one. So I always use my finger as a placeholder. And I'm like, okay, x times x squared, that is x to the 3rd. X times 2x is 2x squared. X times -1 is -1x. And then I'm done with that one. And I move on to my 1, and I'm running out of space. So 1 times x squared is x squared. 1 times the 2x is 2x. And 1 times the -1 is -1. Oh, barely fit her in. Oh my gosh. Now I go through and collect like terms. So x to the 4th is the largest. And then I'm done with that. We got x to the 3rd, x to the 3rd. For 3x to the 3rd. And then we're done with those. X squared, x squared, x squared. So negative and positive goes away, so just 2x squared. And then we're done with those. And then my x's, and I have negative there and 2 of them there, so 1. And then just the number chilling on its own at the end, so -1. Holy smokes. I really prefer to do these ones in a box so that I can't forget anything. Now you could do this good old-fashioned multiply right here, 3 by 3, but that would take up a lot of space. So I'm just going to do this one here as a 3 by 3 box. This video is getting so long. I'm so sorry, you guys. We're just getting lots of good practice in. So I put the first 3 numbers along the top and then the second 3 numbers along the side. And then we just have to multiply to get each box. So 3x to the 4th, -2x, 3, 4x squared. 15x to the 3rd, -10x squared. 20x. Last row. 1, thank goodness, it all just stays the same. Now, if you look along your diagonals, you should have like terms. So that makes it a little bit easier. So 3x to the 4th. And then right here we have like terms. So 13x to the 3rd. And then all of these are like terms. So 7 and negative 10 is negative 3x squared. And then 18x. And then a plus 4. Holy smokes. Oh my gosh. And then I wrote on top of it. I'm going to leave that last one. Should I make a separate video? I should make a separate video. I'm going to make a separate video for these last ones. These are trickier, but we're not going to do a ton of them, so I'm going to make a separate video on that.